Hey guys, I'm back with a new video. In this video, we'll start by solving some simple problems using Java so as to get our hands dirty with some code, and gradually we will proceed with more complex problems. Feel free to solve the questions that we are going to cover in this video in any language of your choice. So first, let us start with a very simple problem. So we have to print all the even numbers from 0 to 10. So right on the screen you can see that I've already created a simple problems.java file. So let us define a class for this, public class simple problems, and let me zoom this up, and then the main method. And now let us define a function in our class. So function in any programming language is a piece of code that runs when you invoke the function, and what it does is it performs all the instructions mentioned right inside the code block one at a time, does the work and gives the results to the caller of the function if asked for. So let's define the print even numbers function, and let us go right above, and here we can say public static void print even numbers. And let us discuss about the idea for solving this problem. So what we have to do is we have to generate numbers from 0 to 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and we have to check whether a number is even or not. So if it is even, then we have to print it to the terminal. So if I start with 0 and we compute 0 modulo 2, then it comes out to be 0. Okay, so this check will hold true, which means that this is a even number. So let's move on to 1. Now 1 is an odd number, so if you compute 1 modulo 2, this comes out to be equal to 1, which is not equals to 0. So we don't have to print 1. Let's move to 2. 2 modulo 2 is 0, so you have to print 2. 3 is an odd number. 3 modulo 2 comes out to be 1, so you don't have to print this. 4 modulo 2 is 0, you have to print this. 5 modulo 2 is 1. 6 modulo 2 is 0. 7 modulo 2 is 1. 8 modulo 2 is 0. 9 modulo 2 is 1. And 10 modulo 2 is 0. So we have to print all those numbers for which if you compute the modulo 2, you get 0. So the numbers for which you get modulo 2 as 0 are 0, 2, 4, 6, 8 and 10. So let us write this logic in form of code. So the very first step is to iterate over all the numbers from 0 to 10 and print all those numbers which are evens. So we need a loop for this. For integer I as 0, I less than equals 10 and I plus plus. Now for all the numbers that we are going to generate, we have to check whether a number is even or not. If it is even, we have to print it to the terminal. So the condition for even number, as I already told you, is I modulo 2 must be 0. If that is the case, we print the corresponding number to the terminal. If I, which is the number that we are currently on, modulo 2 is 0, let's print I for that case. So system.out.print I. So you can see we are going over all the numbers from 0 to 10, and for each number we are checking this condition. If the number holds this condition, we are printing that to the terminal. So let us run the file to see if it works or not. So let us compile the code by saying java c simple problems.java, and then run the file java simple problems, and you can see we are getting all the numbers from 0 to 10 that are even, namely 0, 2, 4, 6, 8 and 10. Now let us refactor this I modulo 2 itself to a new function to be more clear about what the code does. Let us define a function and name it as isEven. So let us go right here and say public static. Now this is going to return a boolean because this is a check. So boolean is even, and this will take a number, and here we are going to check the same thing. Let us cut this out and paste it right here and change this to number. Now for each iteration, pass the current number to the isEven function, and here also we have to specify the type int number. So what we are doing here is that right inside the if condition, we are specifying the function to run on the current number that we are on, and this will check whether the number is even or not. So if this returns true, then we are going to print the number, and if the condition doesn't hold true, then we are going to move to the next number. So let us again check if this works or not, and you can see we are getting the correct output. Now let us solve a simple problem to find the factorial of a certain number using iterative way, but before that let us learn what a factorial actually is. This problem can also be solved using a technique of recursion as well, which we will see in a later video, But before that, let us solve this using iterative way and understand what a factorial is. Okay, so let me erase this first. Now suppose you want to compute the factorial of 3. So the notation for representing 3 factorial is something like this, or you can also say 3 exclamation mark. Now 3 factorial, if you evaluate it, it comes out to be equal to 6. Now 3 factorial is 3 into 2 factorial. Now for 2 factorial you can say 2 into 1 factorial. For 1 factorial you can say 1 into 0 factorial. And 0 factorial has a value of 1. So 1 factorial is 1, so this comes out to be 2. Now 2 factorial is 2, so 3 into 2 into 1 factorial into 0 factorial. So everything comes out to be equal to 6. Now if you want to compute factorial of 5, you can say 5 into 4 into 3 into 2 into 1 into 0 factorial, which is also equal to 1. If you multiply this, you get 120 as the answer. So now we know what a factorial is. Let us solve this problem using code. So let us comment this invocation first, and right here let us define a function compute factorial that I will define in just a minute, and this will take on a number. So let us pass 5 for now, and let us wrap this in a print line statement. So system.out.println, and let us go right here and define the function public static, and this is going to return an integer. So the return type of int compute factorial. This takes on a number for which we want to compute the factorial. So let us define a variable factorial that will store the result and set that to 1. Next we need to make use of a while loop. Now as long as the given number doesn't get reduced to 0, we need to perform some work. So as long as the number is not equals to 0, the very first thing we need to do is we need to multiply the number with the factorial value that we are currently having or that we are currently building. So factorial into equal to number. So whatever current number we are having, we are multiplying that with factorial, and then we are decrementing the number by 1. Now once we have multiplied the number, we are decrementing it by 1 to multiply the decreased number, which we are doing right here, with the current factorial that we computed in the next iteration. Now once our number reduces to 0, because each time we are going to perform an iteration, as long as this condition holds true, and once our number becomes 0, we come out of the while loop and we have the resultant factorial with us, which we can return from the function. So let us return right here. So return factorial, and let us understand this code before running it. So let me erase this first. Now at this line you can see we are declaring a variable factorial, and this has an initial value of 1 sitting right inside it. Let us suppose the user passed a number 5 as the argument to the compute factorial function. Now this condition will run as long as the number is not 0, which is 5, not 0, which is true. Then this line will run factorial into is equals to number. So right inside the factorial we are having 1. We are multiplying 5, which we got right here, to that. So this will become 1 into 5, and then we will decrement the number by 1. So 5 will now become 4. Now again the loop will run. So now we check for the condition 4 not equals to 0. This is again true, and now we'll multiply 4 with the current factorial that we are having, which is 5. So 5 into 4. Then we decrement the number again by 1, which is 3 now. Again we check for whether 3 is equals to 0. So 3 is not equals to 0. We now multiply 3 with the current factorial. So 5 into 4 into 3. And then we again decrement the number by 1. So 2. Now 2 is not equals to 0. This condition holds true. The loop runs again. And then we multiply 2 with the factorial that we are currently having. The number then again decrements by 1. Now it is 1. Now 1 is not equals to 0. We multiply 1 with the current factorial that we are having, and then we decrement the number by 1. Now the number becomes equals to 0. Now this condition becomes false. 0 is equals to 0. So you come right outside the while loop, and then you finally return the value of factorial that you computed, which is 5 into 4 into 3 into 2 into 1, 120. So this was the dry run for the code. Let us run the file to see what we get. So Java C simple problems .java and Java simple problems to run the file, and you can see we are getting 120, which was the expected output. Now let us proceed further and now solve our third simple problem, and that is finding out the greatest of the three numbers. Now let me tell you how we can take input from user in Java. For that we first need to create an instance of scanner class. So let us first go right at the top and import the scanner class from java.util package. So right here, import java.util.scanner. So let us create an instance of scanner class, scanner new scanner system.in. Now using this scanner object, we will be able to take input from the user from the terminal itself. Now let us accept the input for three numbers from the user. So int number 1 scanner.nextInt. So the scanner object has an nextInt method to accept a number from the user. And let us copy this and paste it down below 2 times and change this to number 2 and number 3. Now let us invoke the function right here with the numbers that we got as the input and pass them to greatest of 3 function that I will define in just a minute. And pass this invocation to a system.out.println. And let us go right here to define the function for our third problem. So public static int, because this is going to be an integer, greatest of 3, int number 1, the first argument, the second one, number 2, and the number 3 that we are passing right here. So first let us define an integer variable which will have the final result of the greatest among the 3 numbers. In the start we don't have any maximum, so for the start let us set a variable maximum to -1. Now here we just need to use simple conditional statements to solve this. Now let us first check whether the number 1 is greatest of all or not. So if number 1 is greater than number 2 and number 1 is greater than number 3. So here we are checking whether the number 1 is the greatest among all the 3 numbers. So if that is the case, you set maximum to number 1, else if, let us paste this condition, else if number 2 is greater than number 1 and number 2 is greater than number 3. Now if this condition doesn't hold true, we check whether number 2 is the greatest among all. If that is the case, we set maximum to number 2. As if both these conditions are false, then this means that number 3 is the greatest among all. So maximum, set that to number 3. And then you can return the maximum right here. But what if all the numbers are equal, or if 2 numbers are equal but one number is different? So let us understand this case as well. Now suppose that the given 3 numbers are 1, 3 and 5 respectively. So the number 1 is 1, number 2 is 3 and number 3 is 5. Now in this case, this condition doesn't hold true because you can see number 1, which is 1, is not greater than number 2. So this fails, even this will fail, and this will run. So maximum gets set to 5 and we return 5 right here. Now what if the 2 numbers are same? So this is 2 and this is say 3. In this case what will happen is the first condition will break, even the second condition will break because 2 is not greater than 2, and the third condition runs which says maximum is number 3, which is right. Now what if all the 3 numbers are equal, say 3, 3, 3. Now this condition doesn't hold true, even this condition fails, and we are returning maximum as number 3, which is 3. But here all the numbers are maximum. So we could even have set up maximum right here instead of checking for these conditions. for this case. So what you can do here is that here we can set up a greater equal to for both these conditions, and even then the code will run fine. So let us do that. Greater equal to like this. Now let us run the file to see what we get. So first compile the code and then run the file. First we have to specify the three numbers. So say 12, 13, 14, and you can see we are getting 14 as the output, which is the greatest among the three. Let us again run the file. Now this time let us give two numbers as same and third number as different. So 2, 3 and 2. And here you are getting 3 as the output. And finally, for the third case, when all the numbers are equal, you get 3 as the output. So this works great. Now let us solve another simple problem, and what you need to do here is that you need to count the number of digits present in a number. If the number is 126, the function should return 3 because here we are having 3 digits in the number. If the number is 72, the function should return 2 because here we are having 2 digits in the number. So you can pause the video and try this on your own. So now let us solve the problem and then understand the logic that I'm using here. So let us go right above and define the function public static int count digits, and this will take on a number for which we want to count the number of digits. So first let us set an integer variable and let's name it as counter and set that to 0 as the initial value. And here we are going to store the count of the digits present in the number. Now as long as the number that we got as the argument is not equals to 0, we are going to run some piece of code. Now the loop will run as long as this condition is true. Now once the number gets reduced to 0, the code block pertaining to the while loop will not run and the statement immediately following the while loop will get executed. Now the first thing we have to do right inside the while loop is to divide the number by 10. Now this will reduce a digit from the number. So number by equal to 10. And now once the digit of a number is gone, let us simultaneously spin up our counter as well. So counter plus plus. Now once the number gets reduced to 0, the code right after the while loop will run. Whatever value you have in the counter, let us return that from the function. So return counter. Now let us understand the code by doing a dry run. Now given the number 126, so now the user supplies 126 as the argument to the count digits function. Now the very first thing that happens is we set up a counter variable with an initial value of 0. Then we check for the condition 126 not equal to 0. Now as long as this condition holds true, the following piece of code will run. Now 126 is not equal to 0. That is true. So we compute 126 by 10. So we are dividing 126 by 10. And this gives us 12.6, which is implicitly typecasted to 12. So now our number becomes 12 at this point. And right after this, we spin up the counter by 1. So now our counter becomes 1. Now we again check for this condition. But now our number is not 126, it is 12. This condition still holds true. We divide our number by 10 again. So 12 by 10 gives us 1.2, which is implicitly typecasted to an integer, gives us 1 now. So now at this point our number is 1 in the second iteration. And now again our counter gets incremented by 1. So counter becomes 2. Now the condition is 1 not equals to 0, which is also true. And now you divide your number by 10. So 1 by 10 is 0.1, which is implicitly typecasted to an integer. So gives us 0 now. And again we spin up the counter by 1. So counter is now 3. And now finally if we check this condition, number not equal to 0, which is 0 not equals to 0, and this is false. So we come right outside the while loop and we return the value of counter that we are currently having, which is 3. And this is what indicates the count of the digits in the number 126. So let us run the file to see the output. So system.out.println count digits, and pass on a number that we take from the user as an input. So scanner dot next int like this, and let us comment the above invocations. First the greatest of 3 and this factorial one as well, and let us comment these 3 lines as well. Let us compile the code first. And run the file. Now we need to first specify the number for which we want to check the number of digits. So this, and press enter. You can see we are getting 6 because this number has 6 digits. So this was all about the very first video on solving some simple problems. In the next video we will learn about strings in Java, and then we will proceed with more complex data structures in the coming videos. So let's catch up in the next one.